correlation methods. So here we have the different methods. So first one is scatter diagram. So we can use this scatter diagram method or nothing but graphical method. So by using the graphical sheet, we can make this scatter diagram. And the second one is Karl-Pearson coefficient of correlation. Karl-Pearson coefficient of correlation. Coefficient of correlation. This is the one more method. Next, concurrent deviation method. Concurrent deviation method. Concurrent deviation method. Next one is Spearman's rank correlation. Spearman's rank correlation method. Here we have different methods to identify the correlation. Here in the scatter diagram, that is graphical presentation of the correlation, and second one is Karl-Pearson's coefficient of correlation, and third one is concurrent deviation method, and fourth one is Spearman's rank correlation. So first we will discuss about this what is that scatter diagram. It means by using the scatter diagram or graphical presentation, so we can use this what is that correlation method. So how can we find out the relationship between the two variables according to that graphical showing? That is a scatter diagram. So here we are taking the axis, okay, here in the x-axis and y-axis. Here we are taking the independent variable on x-axis, dependent variable on x-axis, and a dependent variable on y-axis. Dependent variable on y-axis. So for example, if you are taking the price and demand and x-axis and y-axis, so if price increases, if price will be like this, different prices, and what is the demand of this particular demand is going to change according to the price. So for example, this is a price level. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So what is the demand level? If the price is 1, what is the demand? Like this. If price is 2, like this. Price is 3, like this. So here different directions we will get this according to this diagram. That is the nothing but, so by using these lines, we are making a straight line between this diagram is nothing but scatter diagram. Okay, means all the dots we have to put on the graph. Then by using the maximum dots we have to join together. Then we will make a graph. According to the nature of this graph, we can identify either it may be positive correlation or negative, because the graph slopes downwards, because nothing but negative correlation, because the demand and price is having the negative relationships. So because of this, we can identify, we can add the dots by in the scatter diagram, we can identify the relationship between the variables. So some graphs may be like this, means here we have to add with the different dots, means we will get a line, that is the linear correlation, linear relationship. Okay, so that is the line. So some dots may be like this, that is irregular, means no relation. Irregular relation, that is no relation, because it is not at all depending on one variable to another variable, because all the dots we will get here. So by using, we cannot draw a line because of these things. We can't draw any line. So some lines may be like this. So this is nothing but a curve nature. This is non-linear correlation we can identify. So here in these things we can, so this is positive, sorry, this is an inverse relationship, negative correlation. This is positive and linear correlation we can identify. So by using these diagrams, means first of all, we have to take that independent variable on x axis and dependent variable on y axis. We have to make the dot, and by adding the dots, by adding the maximum dots, it will be form a line. By observing that line, if it is positive relation or negative relation or zero relation or linear relationship or non-linear relationship, we can identify. This is the purpose of scatter diagram. How the data will be scattered means first of all we have to make that dots, how that distribution will be scattered on the graph. Then based upon that observing the graph, we can identify the relationship between the variables. That is scatter diagram method. Next, Carl Pearson's coefficient of correlation. So here in the correlation, we have four methods. What are those? Scatter diagram method, Carl Pearson coefficient of correlation, and Spearman's rank correlation, and concurrent deficiency method. So from these four methods, here we are going to discuss the Carl Pearson coefficient of correlation. Here we have covariation. Carl Pearson coefficient of correlation means the covariation of the two variables in a series. So we are taking this variable series and we are considering two variables from that series, and what is the variation between that variables in that series. So covariation, what is the change in between the variables is nothing but that's covariation between the variables. It is related to the Carl Pearson, means it is derived by the Carl Pearson's. So because of this Carl Pearson's coefficient of correlation, here we have two methods to solve this Carl Pearson's coefficient of correlation. One is direct method and the second one is shortcut method. So here in the first direct method, that is R is equals to sigma xy into by n into sigma x sigma y, which needs sigma x and sigma y are nothing but sigma x square by n, sigma y is equal to sigma y square by n. Then x and y are the x is equal to x minus x bar. So individual observation, my actual mean we are taking here, y is equals to y minus y bar. Then it can be written as R is equals to sigma xy by substituting sigma x square by sigma x y square sigma y, then sigma xy square by n. Then the n gets cancelled, sigma xy. Then here R is equal to sigma xy by sigma x square and sigma y square. So that is the formula for coefficient of correlation by using the direct method. Sigma xy by sigma x n into sigma x sigma y by sigma x square sigma y square. So then shortcut method, here we have R is equals to sigma dx dy minus sigma dx into sigma dy by n by under root of sigma dx square minus the sigma dx whole square by n, sigma dy square minus sigma dy whole square. Here where dx dy are the deviations from the mean, here we are taking that mean from, that is assumed mean. Y bar is also assumed mean. So here in this assumed mean we are selecting, here we are selecting the actual mean of the observations. So these are all the two formulas for this direct method and shortcut method. Now we are going to discuss the problem. Yes, here we have the example. Here we have to find out this Carl Pearson coefficient of correlation for these two variables x and y. Here we have the two variables and two observations. Those are all 2, 3, 4, 5, 6, 7, 9, 10, 14, 15. So here two variables we have. So with the help of this, what is that? What is the formula for us to find out the Carl Pearson coefficient of correlation? Here the formula, that is Carl Pearson's formula. What is that? R is equals to sigma xy by sigma x square under root sigma x square into under root sigma y square. Here where x is equals to x minus x bar. So x bar is equals to sigma x by n. We know this. So for this purpose, what are the things we have to identify here? First of all, x, that is equals to x minus x bar. Then y, that is equals to y minus y bar. Then x square, y square, xy. These three columns we have to make. So here first x bar and y bar. So here we need to calculate this x bar and y bar. We need to calculate the, so x bar is equals to, that is x bar is equal to x minus, what is that? Sigma x by n. Y bar is equals to sigma y by n. So to calculate this, 2 plus 3, 5 plus 4, 9 plus 5, 9 plus 5, 14 plus 6, 20. Here 20 by how much it is? 1, 2, 3, 4, 5. 20 by 4 is equals to 4. So that is, what is that? X minus 4. Here we need to calculate. Next, y. Y bar is equals to 7 plus 9, 16 plus 10, 26 plus 14. 26 plus 14, 40 plus 15, 55. This is 55. Then y bar is equals to 55 by how much it is? 1, 2, 3, 4, 5. 5 is equals to 11. So this is 11 and this is 4. So next, x minus x bar. Here x minus 4. Here x is equals to 2 minus 4, minus 2. 3 minus 4, minus 1. 4 minus 4, 0. 5 minus 4, 1. 6 minus 4, 2. Next, similarly, y bar is equals to how much it is? Y bar is equals to, then y minus y bar, how much it is? 11. Y minus 11. So 2 minus 11, minus 9. 3 minus 11, minus 8. 4 minus 11, minus 7. 5 minus 11. Sorry. Here y, it is not x. Okay. So 11, 7 minus 11, minus 4. 9 minus 11, minus 2. 10 minus 11, minus 1. 14 minus 11, 3. 15 minus 11, 4. Okay. Then this is x and this is y. So for our confirmation, may take a capital X and capital Y. So x and y, small x and small y. Then small x square, minus 2 whole square, 4. Minus 1 whole square, 1. 0 square, 0. 1 square, 1. 2 square, 4. So what is that? Sigma x square. We need this sigma x square in that. Sigma x square, 4 plus 1, 5 plus 1, 6 plus 4, 10. Next, similarly, y square, 4 minus 4 into minus 4, 16. Minus 2 into minus 2, 4. Minus 1 into minus 1, 1. 3 into 3, 9. 4 into 4, 16. Here, how much it is? 16 plus 4, 20. 20 plus 1, 21 plus 9. 30 plus 4, 16, 46. This is sigma y square. So here and also sigma xy we need. X into y. Here x, y. 2 into 4. Minus into minus plus. 2 into 4. 8. 1 into 2. Minus into minus plus. 0 into minus 1. 0. 1 into 3. 2 into 4. 8. Here how much it is? 8 plus 2, 10. 13 plus 8. 21. So here this is equals to sigma xy. Next here, now we need to substitute all the values in this Karl Pearson coefficient of correlation. R is equals to sigma xy. How much it is? 21 by 10 into under root 10 into under root 46. Okay. Then by simplifying this value, root 10 into root 46 and 21 by root 10 into root 46. Okay. Here to find out the Karl Pearson coefficient, here we have the two observations, x and y, two variables. It can take the values 2, 3, 4, 5, 6, 7, 9, 10, 14, 15. So first of all, we have to do x minus x bar, that is small x is equals to, we have to find out. Then y minus y bar. So to find out this x bar and y bar, we need to calculate the mean value of these values. Here we got calculated. X bar is equal to sigma x by n. Sigma x, how much it is? 20 by total number of observations, 1, 2, 3, 4, 5. 20 by 5 is equals to 4. Sigma y bar is equals to sigma y by n. Sigma y, 7 plus 9 plus 10 plus 14 plus 15, that is equals to 55. Sigma y is equal to 55 by number of observations, 5. 55 by 5, 11. So here x bar is equal to 4, y bar is equal to 11. Then here x minus x bar, nothing but x minus 4, and y minus y bar, that is equal to y minus 11. So x bar is equal to 4, y bar is equal to 11. Then this is the individual observation, that is equal to x. X minus x bar, that is 4. X minus 4, that is 2 minus 4, minus 2. 3 minus 4, minus 1. 4 minus 4, 0. 5 minus 4, 1. 6 minus 4, 2. So that is the values of small x. Then similarly, y minus y bar is equals to 11. Y is equal to here 7 minus 11, minus 4. 9 minus 11, minus 2. 10 minus 11, minus 1. 14 minus 11, 3. 15 minus 11, 4. So these are all the individual values of small y. Then we need to calculate according to the formula sigma xy x square sigma y square. So for this purpose x square, what is the small x values? -2, -1, 0, 1, 2. We need to square all these values. -2 square 4, -1 square 1, 0 square 0, 1 square 1, 2 square 4. Similarly, y square. Y values are -4, -2, -1, 3, 4. -4 square 16, -2 square 4, -1 square 1, 3 square 9, 4 square 16. So we need to make the summation of all these sigma x square. That is 4 plus 1, 5 plus 1, 6 plus 4, 10. Then similarly, y. Sigma y square we need to find out. 16 plus 4, 20 plus 1, 21 plus 9, 30 plus 16, 46. That is sigma y square. Similarly, we need to find x and y. Here we have x, y. -2 into -4 plus 8. -1 into -2 plus 2. 0 into -1, 0. 1 into 3, 3. 2 into 4, 8. So we need to make this summation of this x, y. That is sigma xy is equals to 8 plus 2, 10 plus 3, 13 plus 8, 21. So all these values we got. What are those values? Sigma x square 10, sigma y square 46, sigma xy 21. Here, what is the Karl-Pearson coefficient of correlation? R is equals to sigma xy by sigma x under root of sigma x square under root sigma y square. So we need to substitute all these values here. R is equals to, what is sigma xy? That is equals to 21 by under root sigma x square. Sigma x square is equal to 10 and under root sigma y square. Sigma y square is equal to 46. Okay. Next, R is equal to 21 by sigma 10 is equal to 3.16. Under root 10 is equal to 3.16 and root 46 is equal to 6.78. Then R is equal to 0.98. Here R is equals to 0.98. It is showing the positive relationship. So because of these two variables x and y are in positive correlation. So this is the decision we are going to give. So x and y are in positive correlation because it is showing the positive R. Correlation coefficient is we are getting the positive.